when we have a really long function with a lot of different terms being added and subtracted together, it's the best when we can use the sum and difference rule, right? Which just means that, let's say I have, maybe I'll call this h of x to make it a little bit less confusing. Let's say I have a couple functions, f of x plus g of x, and I want to find the derivative of that entire thing. Well, that's going to be the same thing as doing f prime of x and g prime of x separately. Some people get confused with the notation, right? F of x, right? I don't have two different functions, but we can treat this piece as f of x, and then this piece will be our g of x, and then this is a different function and a different function, right? Each piece, each term we can treat separately. Oops. Let's do it. Ooh, difference. Same exact thing as sum. So I guess if we're subtracting the two functions, well then we just have to make sure we're subtracting the two functions. But let's get into it. All right, taking the exponent, drop it to the front. 3 times 7. Yep, I can do this. 21. 3 minus 1, 2. Minus 2 times negative 2, we got minus 4x. Then this is x to the first power, drop the 1. 1 minus 1 is 0, so this is just plus 3. And then the 6, because of that constant rule, right, or technically this is x to the 0 power. So when I take that 0 exponent and drop it to the front, 0 times anything just goes away. So our h prime of x is equal to this. All right, the sum and difference rule is really going to come into handy when we have like a bunch of different functions. Like what if I had a natural log plus a cosine of negative x squared plus a, right, we have a bunch of different types of functions in one. For polynomials, it just makes it really easy. 2.